Welcome everybody, welcome back to the very short lecture of number 39, I guess.
Yes.
39. Today we spent it solving the quiz, and this is the solution of problem
Number
2 of the quiz, which is similar to the class example. What we did is we assumed a zero ideal voltage drop. You can change the battery. Originally it was plus minus 5 here. So you can do it with minus plus 5. You can keep it the same. The numbers will be the same. You identify I1, I2, and I3. You start writing the loop equation. Loop 1, minus 5, minus 100, I1 minus I2, minus 200, I1 minus I3 equals 0. Loop number 2, minus 250, I2 plus 100, I1 minus I2 equals 0. You have two resistors here. If you have the 0.7 drop, you can include it here, but you might get different numbers, I don't know. The last one is this equation, which is voltage rise of 200, I1 minus I3, voltage rise of 0, voltage drop minus 100 of I3. This is I1, I2, I3 equal to 0. Create the system of the equation, solve it, you'll get I1 is that, I2 is that, I3 is that. All of them are negative. However, ID is I2 minus I3. And ID was 0.0138 positive. So our assumption is wrong. ID is positive, VD is 0, the diode is on. Why it's on? From a very smart initial guess, this is minus 5 volts, so we guess the cathode of the diode is more negative. For more information, those who are watching on YouTube, I'm going to upload the solution of the quiz so you can read the problem. It's similar to the example, but we reverse the direction of the diode. And we added a negative to the battery. Okay? And we didn't assume a 0.7. Any question? Any question, Turkey? Awesome. You have a question? You understand this example? If we bring it in the final exam, can you solve it? Mishal, do you understand it? Shaheen? Jihad, you have questions? Okay. So next week we will continue the digital design. Please fix those two examples that we solved in the quiz in your mind. And don't tell the other section about the quiz.